new learning for us. The learning here is, so let us remove this. So what is the learning for us here is, this data is not comes under like a raw data. So all this time we are using a raw data. For example, HR benefits come from CSV format. Raw data means rows and columns are clearly given. We have maybe 13 columns because 13 variables, and we have 17,000 rows. But now, and the one of the objective of doing this exercise is, when you are doing some kind of analysis, or if you are reading the some journals, they are clearly given a correlation score and a mean score and the standard deviation reliability score of the as a fundamental analysis of any kind of latent based analysis. That is quite important. The reason here is, even if we can able to take out the correlation score and standard deviation, we can create the same output by using the R method, or even that can be done even in in AMOS also. So now the objective of the session is how to just do the data input in a different format rather than a raw data. If it is something like correlation matrix or something covariance matrix, how to do that. That is the purpose of doing this. So you can see this is a correlation matrix. So we are just arranged a data in a simple way like this. Okay, and we are using a function called LAV matrix lower to full. So let us see what is this LAV matrix. So LAV matrix, you can see lower to full. So what it shows me is utility function for matrix and vector operation. So we are arranging the data in the form of lower correlation matrix or lower order correlation matrix. So this all nothing but your score, the correlation score. So we'll just select these things and run it, and it got accepted. So it got stored in the form of a data object called data.cor and cs. Then further we are just going to the original data. The original data name is here CSI, and we are just running the standard deviation for all this variable by applying the apply command, by using apply command. So this will fetch you standard deviation. So if you just run this command alone, so we are getting a itemized standard deviation. Okay, then we just want to give a row names and column names as the same. Okay, so that is how this command is working. That's the purpose of this command. So if you just run this command, so now you are going to get this way. You can see that. So we are getting all the correlation matrix with the proper rows and column name. The next job here is what we are going to, we have to convert this correlation to covariance matrix. As we are aware that SEM by default it accepts a covariance matrix rather than correlation matrix. What we have a correlation matrix, but easy to convert in R. There is a function called what we can call as core to COV. It's a Lavant function. It shows a convenience function to deal with the covariance and correlation matrices. So simply to just convert from a correlation to covariance matrix. So in that we have two arguments. One is your data in the form of correlation. Other is a standard deviation. So we have to pass two argument here. So once you pass a two argument, then see how it look like. So this is how it look like. So we got a covariance come your standard deviation also. So now our data is ready for data analysis. So what we are doing all this time, we take a raw data input from CSV or from SPSS or from Excel. This time the data not in the form of rows and column, it is in the form of a correlation score. So we are just bringing that correlation score inside the R by using what we can call as LAV matrix lower to full correlation. Once we get it, and parallelly we are computing standard deviation, and we are trying to knot both the things by using the function called core to covariance. So this will give a raw data. Now raw data is ready for us, but we have to understand that we never mention what is observation here. So we are just mentioning only the correlation and standard deviation. Now the next job here is as usual we are just trying to make the order. So there is a 3 latent, and each latent has got set of items. So there's a block comments charts here. So my model fit name is CS. So select and run here. So it accepted. Now you can see that all this time we have just done only we have done data and the model, but here it is little bit of different. This CS is a what we can call as a model, and sample.covariance is the data set which is the form of covariance and standard deviation is present there, and this is what we call as sample number of observation. So I already informed that we don't have the observation in the data set, but we have to mention observation here. Okay, the observation here is 546. So control enter. So it accepted. Now before we are getting into any kind of CFA model, um, the best practice is what you have to do, that we have to just examine this correlation matrix and covariance matrix. The reason here is when you just running the correlation matrix, we can come to know that whether correlation figures are within the bound. It should not exceed 1. If it is exceed 1, then we can figure out there is some kind of mistake in the beginning itself. So we'll run two correlation and covariance parallelly. So you can see that it shows the figures are lat 1, lat 2, lat 3 like 0.774, 0.403, 0.358. So all seems to be fine. So there is no such concern at all. But normally in the covariance it should go more than 1, or sometimes it may go more than 2, 3 like this also. No need to bother about, or botheration only for a correlation. Fine. The next job here is we have to fit a measure. So here the object name what we are combining all the three things, that is called model, sample covariance matrix and observation is a fit. So I will pass this fit inside the summary and we'll run the analysis. And now you can see that last time when you do, we just made a fit measures when we get so many things. Sometimes we may not get all the indexes, but this time I'm just mentioning these all the indexes what we required. So we got the output also. If you see this output, this is how the output look like. So we already we understand how to read this output. So that is not our botheration. I'll straight away come here and we can see all the Z values are more than plus or minus 1.96 and P values are almost 0.00 and standard all is all are almost close to more than 0.5 except few things are like 0.3. So this ensure that model look like a good for us. So this is what we can call as a latent and this is what we can call as a error correlation. So I don't want to repeat the process once again. This is what we call as correlating the latent and this is what we call as correlating the error. With the help of modification indexes, we have just done that. And in terms of variance, you can see none of them is very big score in the estimation and there is no negative covariance and there is no variance never exceed more than 1. So this all indicating statistically our model looks good. Now the next job here is this we already learned, nothing is new for us except the how to impute the data in the form of a covariance matrix to the R.